Hello, 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 ladies and gentlemen, and welcome back. Root Beer here with our second last question, not the last question, the second last question, number 24 from our 2011 Pascal contest. So, what have we got here? Let n be the largest integer for which 14n has exactly 100 digits. So it's going to be a little less than the smallest number with 101 digits because we want the largest one. So it's going to be less than 10 to the 100, 10 to the 100. Not 10 to the 101, 10 to the 100 because that's a 1 followed by 100 zeros, and in total that would be 101 digits. Okay. And then what do they want? So they're telling us about this n. Counting from right to left, what is the 68th digit of n? Interesting. So I don't think there's anything particularly special about the 100 digits, so what we might try and do is look at smaller cases and see, hey, can I notice any patterns or anything like that? So, for example, we'll get our last question out of the way. We might start with something small. How about 14n less than 100 squared? What does the n look like there? And unfortunately, we've got our calculator. So we could do, now I want the biggest one, so I'll take 100, I'm going to divide it by 14, and that gives me 7.14285. So I'll round down, 7 is the largest possible n that'll work here. So n looks like 7. Okay, not particularly interesting, but what if we did 1,000? So I'll take 1,000. Now we still need to be less than that, so divide by 14, round down. Now I'm noticing I get 71.4287. It's kind of interesting. If I take 10,000 and divide by 14, yeah, I get 714 when I round down. So it's kind of interesting. Looks like we've got 714,285, and then it repeats 714. And now my calculator is showing a 3 here, but of course they're rounding up from the 28. Okay? And this makes sense. If we divide, if we're looking for 14n needs to be less than, say, 10 to the k, divide both sides, you'll get n must be less than 10 to the k over 14, which is really 5, 10 to the k minus 1 over 7. So it's 5/7, just multiply, you just move the decimal place over a certain number. So what does 5/7 look like? Well, 5/7 looks like 0.7141. And so for 10 to the 2, we move the decimal place over 2 minus 1 places, and that gives us the 7.1. And then with 3, we move it over. Okay, so if that's the case, for 100, we are looking at 5/7 times 10 to the 99. So our number would start, now I'm starting over here from left to right, and this number here is going to have 99 digits. But we're going to have 714,285, and then it repeats, so 714,285, 714,285, and it's just going to keep going. Now it'll stop somewhere. I don't know exactly where it'll stop. We could probably work that out. But actually, the pattern repeats every 6, and I need 99 digits, so the closest multiple of it should be 96, so it'll end 714,285, and then it'll go 714 again. So that's what the number basically looks like. Now, what do I want? I want the 68th? 68th digit counting from right to left. So this is digit 1, 2, 3, 4, 5, 6, and then it repeats 7, 8, 9, and so on. Now 68. 68 divided by 6 is 66. Okay. So this will keep going, counting up now this way, because we're counting from right to left. And so then it'll go 4, 1, 7, 5, 8, 2, and that'll be the 66th, 65th, and so on. And then it'll go 4 again for the 67th, and then 1 for the 68th digit. Okay, so I'm declaring our answer to be 1, and that's A. There we go. I just needed to sort of work out the pattern. It just turned out to be 5/7. I just need to find our way. Now, you didn't have to go all the way to start from the end. You could have said, okay, 99 digits. We want the 68th digit. How many do I need to count over from the left? That would have been fine. Could have saved you some time, but I'm happy with what we did there. All right, so that was question number 24. In the next video, we're going to take a look at question number 25. I'll see you there.